Welcome back to the course. Now we are talking about geothermal energy. It's our third renewable energy, which will be followed then by biomass and solar. So let's start with the geothermal energy, the definition, which is a form of energy conversion in which heat energy is captured from the earth and harnessed. So how does it work? So the idea is actually to drill down to an aquifer which is very close to a hot volcanic rock, and from there we need the heat source should be above 120 centigrade. From the drilling that will be in a piping, the hot water will be piped to a geothermal plant, and there it will be a generation of electricity. It can be also used for district heating. So how does it work? The hot water 120 and above goes into as steam. It goes into the generator and is producing electricity. The residual heat can be used for, as I said before, as for district heating. Normally the water will be then go back, which is not shown here, into the aquifer. So let's talk about the advantages and disadvantages. So of course it's a renewable energy, so the carbon footprint should be low, actually none or very low, depending on the operation, because you still need some electricity on site. It's a reliable energy source for 24 hours, 7 days a week, the whole year, and with normally only a few interruptions. And you can use it for heating, district heating, and for electricity, as well as direct utilization, like using it in a bath or a sauna or something like that. Disadvantages is that you sometimes do not know exactly which kind of liquid water you get there. So it could be acidity of the water could lead to erosion. It also, which I will discuss later on, can lead to surface instability. Environmental and social constraints would be, for example, that you don't really want to have a geothermal plant in the area where you have a health spa and sauna and recreation area. Another point is, which I also will go in detail, is the financial constraints, and that will be the following slides. So financial constraints here is that the drilling makes already a big part, and if you put the test drilling together, it's even more than the construction of the power plant. So there are very high investment costs. Surface instability, it can lead to earthquakes. We had some in Bavaria with geothermal drilling combined, and particularly if you go for hydraulic fracturing. But there are also other ways which can lead to some surface instability. Is, for example, it was in Staufen in Germany where they drilled a hole 140 meter deep into a water aquifer. There was a very high pressure, and that water went into another layer of soil, which was gypsum, and the gypsum absorbed the water and was like a dry spong before, and then it expanded. It expanded to till now to 62 centimeter in height and 43 centimeter in wide. That led to a lot of damage to buildings and gas pipes. And it's still ongoing. So what's the potential in Mongolia? So we have potential here. All the black dots are hotspots. Now, not hotspots, hot springs. And we have also some tectonic plates areas here in Ulaanbaatar. So the potential is there in these areas and in these areas. For electricity generation, this area here in Sarangui Yud is quite promising with temperature heat, with the heat of the water by 160. The minimum is 120. So as I mentioned here, so we have 42 hot springs, and their direct use is actually for health resort, for bathing, small scale greenhouses, even to grow vegetables in the wintertime, space heating. And I'm not sure if this is already the practice for cashmere and washing and drying cashmere wool. I think it's proposed to do that. So, but I think this is the one which is actually more interesting for you, and that is a geothermal in combination with a heat pump. So we have geothermal heat pump, GHP, and the ground source heat pump. Same thing, just called differently in different countries. So you go in a shallow depths around 6 meters and a little bit more, and you should have a constant temperature of 12 centigrade there. So you're actually getting for that heat sinks of the 12 centigrade and pumping it up via the heat pump into the building. And there the heat pump, it works like in a nutshell, like a refrigerator, and is warming up the house there. I put you on the next slide. I put you a link where you can see this in detail in a video. I could not download the video here on the slide because it would take too many bytes, but please have a look there. It's on YouTube. So here in a nutshell, again, winter heating, you get the cold air from the room temperature, you get it in uh, from the house, you get it through the piping system and goes back to the house. So it should have 12 centigrade here, and with this additional heat from the 12 centigrade here, you actually, with the use of the heat pump, you are producing energy you want for the heating for the house. So we have 4 different versions: the vertical one, the horizontal, slinky, and the pond. The next slide will show you kind of the pond version, or connect with groundwater, and the vertical one. These two are already, we have seven functioning, I think they are functioning geothermal heat pump applications in Mongolia. They're all in Sumot. And you have one with the hotel here, which is based on the water. Unfortunately, only 6 centigrade there for the water temperature, which is of course not as cold as the water or as cold as the ground temperatures is, as less efficient is the heat pump. But here you have the vertical type. So 6 centigrade, 8, and 6, and the vertical pipe there. More information you can find on that link. And here's some comparison. Please, these comparisons are a little bit tricky. So it's from a new study in Covot, and it's a comparison between the existing district heating and a new geothermal heat pump. And you can see, the maintenance costs are easy down, both the same. It's just a maintenance cost for once a year. Annual operation cost, the heat pump is higher because the district heating is very cheap in that. And annual cost, of course, it's the investment. It's much higher. It's all in euro. And the total cost of heat in district heating is only 67 euro. For the heat pump, it's 400. So this comparison, you see the big difference, but it's very difficult to compare actually an existing system where you don't have the investment cost anymore and a new system where you have the investment cost. And you can see these are actually the investment costs. So the running cost would look differently, much different. Then there's another comparison between the geothermal heat pump and the coal-fired boilers, also existing system. The baseline is here, 100% based on fossil fuel. And for the geothermal pump, you have a 75% reduction because of the use of the heat pump. But you have a leftover of the 25%, 23.7%. That the residual one is depending which kind of energy source you're using to generate the electricity for the operation of the geothermal heat pump. Okay, that's so far, I think, from the geothermal energy, and the next one will be biomass. Thank you for listening.